Hello, good afternoon everyone, and thank you for joining us for the fifth webinar in the SELCAN series. This one's around low carbon technologies. My name's Heather and I help facilitate the running of the SELCAN network, who are your hosts today. And we've got two of our members, Georgia Thompson of the Environment Agency and Phil Callow of Ark ICT. And they've got a fantastic presentation to share with you, and we'll be looking at some case studies this afternoon. If you have any questions as we go along, please pop them in the Q&A chat and we'll look to answer those at the end. And I'll hand over to Georgia now. I hope you enjoy the presentation.
Yeah, thanks so much, Heather. So I'm Georgia Thompson. I'm a communications and engagement specialist for the Environment Agency, and I've been working on the Boston Barrier project for the past 8 years, but I'm now predominantly focused on the Lincolnshire Open Coast. So I'll try to answer as many questions as I can going forward, but please note that my knowledge is it's more broad on the barrier than it is specific. And not engineering focused. If you click through, Phil, for me, that'd be great. So kind of to give you a quick history, I'm going to go through a bit of the background of the Boston Barrier because the project itself, will become a defensive front line against climate change for the people of Boston, which is fundamentally what SELCAN's about. So Boston in Lincolnshire has a history of tidal flooding. Basically, it was flooded in 1953, 1978 against the tide, and in 2013, which is probably the one that most people will remember. So as a background and all of that as well, in 2015, it was ranked one of the most deprived areas in the UK, so 66th most deprived council area in England. So really kind of underpinning that, is without a reduction in that flood risk, kind of Boston's, issues could have escalated and increased. And with sea levels predicted to rise by over 1 metre in the next 100 years, those new regeneration projects for the town, weren't really likely to take place. We now know that they have been, which is brilliant. So why does Boston need that barrier? So if you have a look through the pictures, obviously the flooding in 2013, a tidal surge reached 6.08 metres AOD. That's above ordnance datum, which is the measurement of the tide we take in the Environment Agency. As you can see from the image, the defences were overtopped, damaged, and in some places breached, and over 800 properties flooded across 55 streets. So if the barrier had been in place in December 2013, it could have prevented the town from flooding. So what happened that night really galvanised the need for that tidal flood protection for Boston, for the barrier. So previously around town, the defences averaged about 6 metres. So as I said, it went to 6.08 on the evening of the 5th of December 2013. So just overtopped those defences within the town. And the new barrier and surrounding floodwalls are built to 7.55 metres, so a 4.5 metre higher than in 2013. So not just that, flooding has a massive impact to life. Although the waters disappeared quite quickly on 5th December 2013, it was really close to Christmas, and with the furniture that was out on the streets, there was also Christmas trees, decorations, toys, and some of the people there, those family homes, they were out of it for months at a time, and that constant fear when you actually get back to your house of flooding again, that psychological impact has just as much impact as those physical impacts sometimes. If you click through for me, Phil. So this is the project. So in December 2020, the barrier was officially opened. So the barrier will be operated when a tidal surge is imminent. and will be triggered through our the Environment Agency's forecasting system. So the barrier will also be closed for testing, exercising, but basically when that tidal surge is predicted on top of a high tide, that's when we'll be closing it. So outside of those times, the barrier will be open, which will allow boats to kind of navigate through. And it really should only be raised in the coming years, about 1 to 3 times a year against those high tides with the predicted surges. But we know that over the next 100 years, with climate change, with 1 metre sea level rise, that will become more frequent as the years go on. So the key benefits for the scheme, it actually offers better protection to 13,700 properties, you know, and that's not just kind of people living there, that's the schools, hospitals, roads, you know, with and it should deliver those kind of economic benefits of over £1 billion. And when I say over £1 billion, we just stopped counting after £1 billion because there was no point. It was economically viable to build. So far on site, we've spent over £11 million in the local economy. We're also introducing some improvements to the Mill and Wave footpath. So that's a long distance footpath which runs alongside the banks. And we've introduced some internationally rare plant species called the Boston horsetail in the area. And there's also the potential flexibility for the barrier to be utilised for water level management in the future once agreements have been made. So if you could move me on. So if you could just click the video, Phil, and it'll start playing. So this is Monday the 8th of April this year when the barrier was raised. This was the 5th time that the barrier was raised in Kanga in Boston. And it was raised at 2:30 p.m. I was there in preparation for that high tide at 6 p.m. The tide came in slightly under the forecasted levels. It came in at just over 5 metres AOD. But as you can see, the difference in the levels, the top left as opposed to the bottom right, it's quite a big difference there. So just for context, this tide, 5 metres, just over 5 metres AOD, 2013 floods were 6.08. So that's a full metre would have been on top of that to kind of reach those levels. But this is the general kind of level that we would be operating the barrier, we think, in the next few years. So next one. So I'll go on to what I'm supposed to be talking about today, mainly, which is the challenge. So the challenge with any project like this is you know, the carbon amount. So as you can see here, huge amount of concrete. You know, it's a hugely, it could have been a hugely carbon intensive project. And you know, you just don't really see that now when you actually see the river going through the barrier. This is a video too, so if you could just look up on this, you can see the barrier actually being raised without the water in it. So the gate itself is 362 tonnes, and it has 11 metre high rising sill sector gate, and it's powered by 2 55-tonne hydraulic rams. So the forces that are exerted by the barrier and the rams, you know, have to be really, I'm trying to think of the word for it. The structure has to be really, really strong, basically. So it also needs to meet that 100-year design life, including predicted climate change, and you've got, you know, quite high salinity within the water as well, which could, you know, cause some cement concrete to kind of, you know, sprawl in those conditions. So it is a really it's a really intense kind of area, and it needs to be very, very structurally strong. So in the UK, concrete is the major source of carbon. It accounts for 1.5% of all emissions in the UK and 8% globally. So every year we use nearly 12 million tons, of cement in the UK, equivalent to the weight of more than 100 aircraft carriers. So we needed a solution for Boston that would help better protect the people from the tidal flooding. But with climate change and sea level rise becoming a very real threat, we didn't want to add to the problem. So what did we come up with? Click through, Phil, for me. So number one was the barrier recess. So by precasting some of our primary gates recess, which is the curved structure that the gate sits in, we ordered a lot of prefabricated reinforcement cages, and we did a lot of that casting off-site, and moved it into place. So we weren't having to do any additional pours or anything like that. And it actually took 7 weeks off of our programme's critical path, and actually significantly improved kind of the health, safety and well-being aspects of the project. So it meant that people weren't working in confined spaces, etc. So number two was the clash detection that we used. So another carbon saving design decision was that we did very extensive 3D CAD modelling to enable kind of clash detection, which kind of verified the design and meant that rework on site wasn't needed or required. So we used some key learning from the agency's Ipswich barrier team, where they cast their gate on site. And it was kind of suggested to us as a key learning point that prefabrication, that doing it off site and then pulling it onto site and putting it into place that way could simplify the process. So we made some 3D solutions, and we generated those 24 precast units off-site, and it enabled us to install them in 3 days, which took a lot of time off the programme. So the next one was the prefabricated reinforcement. So the rebar that we used on site, we did a lot of kind of virtual construction rehearsals, which influenced how we kind of fabricated it, and helped with the installation process for those kind of really complex works. It looked like a massive connects kind of thing. So within those kind of components, we ordered some. That when we ordered those prefabricated rebar cages, it cut that installation process down to 2 weeks when it could have been 2 months, basically. So again, improve the health, safety, well-being aspects as well on site, and saved 7 weeks in total, all of that together, off the programme's critical path. So kind of this really kind of shows what underpins like the whole of the project. So number 4, the build it twice kind of concept or more is we have a extensive business information model for the whole project, and by developing the design, we through multiple users, we have this common data environment. So it means that all of the people that work on the Boston Barrier can look on the model, can actually see it in a 3D space, and it allows us to kind of, work in that same space, store and develop that information together. So we took a 3D point cloud of the project area before we started, and just added more and more elements as we went on, which meant that we could actually build it in a virtual world before we built it in real life, which obviously saved quite a lot of effort and carbon. So number 5, the control building innovations. So by developing the design of the control building, we actually moved some of the critical plant, things that would usually be stored on the first level of a building like this, because it's so heavy. We actually moved it to the first floor. So we waterproofed. But it kind of took out the waterproofing element of doing the things on the first floor, which meant that we didn't need piled foundations anymore, and it meant that 70 tubular piles could be removed from the design itself. So this saved 360 tonnes of embodied carbon, which is around £300,000 in project costs, and reduced the construction time by about 4 weeks as well. So on top of that, I'm going to whiz through some of these. So we've also got solar panels on top, air source heat pumps as well. So the solar panels, I think, should reduce about 16% of the building's electricity, and the air source heat pumps is about 25%. So another one I'm just going to touch on, because I'm doing a presentation on this in a few weeks. So if anyone's really interested in it, please do attend that. Is the United Nations Sustainable Development Goals. So basically, these development goals kind of recognise the interdependencies between sustainability and the environment's need for growth. So we retrospectively incorporated ours on the Boston Barrier, and it kind of worked as that element of looking at the benefits of what the scheme can provide on a whole. So we fed back quite a lot of these kind of retrospective benefits back to the Environment Agency and back through our delivery partners, and kind of through that shared learning process, it led to something that we're really proud of, which is basically the Sustainable Development Goal framework has now been rolled out across the Environment Agency nationwide. So something we're really proud of. So one of those SDG targets, number 12, is responsible consumption and production. And one of the benefits that we identified through this was actually we reused some backfill from the reuse of dredge material. So the dredger goes out and it needed to kind of take a lot of that kind of clay core from the bottom of the river, but we were going to kind of use some lorry movements and kind of store it off site, but we identified a local landfill site that we could cap off using those materials, and it saved 30,000 lorry movements, which I think is the equivalent of a lot of flights to New York. So move on. So just quickly to kind of recap, we've already talked about how much carbon we've saved in inverting the design of the control building, things like that. Our teams are really carbon aware, and the ethos is that low carbon also saves money as well, makes financial sense. The concrete mix for the structure that we used incorporates 70% granulated blast furnace slag, so that's GGBS, which is a byproduct of the steel industry and iron industry. So that kind of saved, it was 1,250 tonnes of carbon emissions across all of the concrete that was required for the barrier structure. So we know that the scheme provides better protection for thousands of homes, and will continue to do so over the next 100 years. But with the incorporation of that kind of design innovation, we're hoping that the blueprint for the barrier, can help other teams and other people going forward, and hopefully save some carbon in years to come from some of those shared learnings. So it leads me nicely to my last point, which is, what will you do? So 70% of the world's CO2 emissions can be traced back to infrastructure, and 45% of EA carbon production comes from infrastructure construction. So as I said before, we're really mindful that within our climate mitigation, we don't actually add to that problem. So we try and share our learning wherever we can. Over 7,000 staff within the Environment Agency are now accredited with the Carbon Literacy Trust, with the idea that we'll go on to spread the word, kind of like I'm doing today. So as the Environment Agency, we have to lead by example. Our name says it all, with the Environment Agency, but climate change won't wait for businesses to catch up. So what can you do? I'm hoping now that's given you some food for thought, but I'll nice segue into Phil's talk. He's doing some amazing things with his company, Ark ICT.
Lovely. Thank you very much, Georgia. That was really interesting and a great way to highlight how, for anybody that's working in construction or development, managing that embodied carbon can really make a big difference in terms of those efficiency savings. So that was really interesting. And also often when we talk about environment and projects in relation to climate change, we talk about well-being and health benefits. So it was really interesting to get your insights into sort of the impacts of flooding and why this project was so important. So thank you very much.
Thanks, Heather.
Okay, well, I guess I'll take over at this point. I'm Phil Callow from Ark ICT. We are an IT company based in Spalding in Lincolnshire, and I'm going to run through a few bits and pieces that we did as part of our building project. So we moved from an old building to a purpose-built location where we implemented a few different bits and pieces. Now, I will confess I'm in no way an energy saving or a carbon sort of specialist, so this is purely sort of a few ideas that we came up with as we were building the project. So we unfortunately chose the worst time that could possibly be imagined to build this after COVID, when the world's construction industry seemed to start back up again. So some of the costs did go a little bit more haywire than we were expecting due to that sort of global return to construction. But we completed the building work in October 22, which is pretty much when we moved in. And we very much built the whole sort of setup with energy saving at the heart of what we were trying to do. So it includes things like 10 centimetre insulated cladded walls, electronically controlled lighting, and we also utilise a district heating system as well, which I'll sort of come back to. We split it into two separate units. We weren't quite big enough to utilise all the space, and we've rented one out. But in doing this whole project, it's one of the only businesses I am aware of that is a kind of a traditional cladded industrial unit that has an A+ energy rating. So as we were building sort of the whole structure, we were obviously lucky. We started from a greenfield sort of site, as it were. We are in the middle, as that image shows, of the industrial area of Spalding, and it just so happened to be a sort of a field that was separated or surrounded by other industrial buildings. It also has a high pressure water main that runs corner to corner. So if it looks like our building is weirdly in the corner of the plot, it's because we have to stay 3 meters away from this water pipe, which allegedly, if we'd nicked the corner of that, would have caused a 100-meter fountain to occur in Pinchbeck. So we avoided that pipe. As part of the design, we wanted to make sure we were building, a building that also looked cool, looked quite trendy, and is built around our corporate colours. And the roof was also specifically angled to allow more of an optimum angle for solar. So the building luckily faces pretty much due south. and I think the roof was built to an angle of around 15 degrees. We've got 40 kilowatts of solar on the roof that produces more than enough energy unless we're charging vehicles, which I'll also come back to. But 40 kilowatts is way more electricity than we can ever use, currently. And we've also got a bit of scope, as you can see on the building, sort of just behind the graduated roof there. We've also got a bit of scope for adding additional resource on there, which we're hoping to do in the future, with maybe adding some more sort of power generating, also some heating facility, and maybe even a wind generation on the roof as well, as it's sort of flat, so it'd work quite well from the wind coming across the field. We also, again, because we had the opportunity, I realised that not everyone is going to have the chance to build a new building, but we put LED in throughout our building. So I've taken a couple of pictures there, one of our meeting room, and actually we was quite surprised with how many options there were in and around LED lighting that looked quite cool. So you'll see the image on the left there. We actually chose to use lighting which also illuminates vertically. So we chose to keep our roof completely clear of suspended ceilings for most of the areas. Happens to be that I'm in one of the rooms that we did put a smaller roof on, but most of our main areas are actually open all the way to the ceiling, and we utilise the LED lighting to also kind of make a display of all the steelwork and things that are in the ceiling. We also use movement sensors, so you'll see an image on the right hand side. It's a lot of white things on a lot of white things, so hopefully you can sort of pick those up. But in all of the areas that would have natural movement in them, so the kitchen, the toilets, the warehouse, the stairwells, and some of the corridors, they do not have light switches at all. You cannot turn the lights on or off. They're all illuminated by movement sensors only. So that means that if there's nobody in the warehouse, all the lights will turn off. If there's nobody in the toilet, or if you're in there a little bit too long, the lights potentially go off as well. So it was a good way of just ensuring that, the normal thing is you turn the lights on and you will leave them on all day in an office block or somewhere like that. That can't happen. They're all on automated solution. And we also have a sort of external floodlights that we've got on an automated control, so that we can turn them on and off electronically and remotely, but we also have them on a schedule that automatically adjusts the time depending on when the sun rises and the sun sets, which again wasn't an expensive thing to do, and it's all built within a simple sort of control app that we use for even our heating of our water in the summer when our district heating is off. So we utilise a district heating system. It just so happens that we are 200 metres away from Glenfarrow, and Glenfarrow do wood boiler and wood sort of solutions, boiler solutions, as well as district heating systems. And through the process of us buying the land, we kind of had a throwaway comment one day, well, why don't we just plumb into your boiler, as they already had one outside? And actually we thought about it a bit further, and there was no reason at all why we couldn't plumb into their boiler. So you'll see on the image on the right hand side there is a big pipe on the very right hand sort of low, the bottom right hand corner. That is our water return pipe that goes 200 metres from our building over to Glenfarrow, and it constantly moves around hot water from their boiler to our hot water system there, and warms up our water that we use for in the taps and washing up and things like that, and also fully runs our heating solution. So all of our rooms have got radiators in it, but because it is using water that is sent around a mass system rather than us having a separate boiler, it's way more economical and cost effective to run, because it's one system being utilised for lots and lots of different buildings. And our old pallets and waste wood also go over to there to be used as fuel. So bits of old broken pallets and those sort of things go over to be utilised that way. And during the winter months, it's heated via that route. And in the summer months, we move over to using a immersion heater that is on an electrolytic control, but is also run by our solar instead. So even on a bad day, so today's very cloudy, but we are getting somewhere in the region of between 8 and 10 kilowatts even on a cloudy day, which is more than enough to run most of our sort of core systems. We're also planning in the future to connect potentially into, we built a T-piece in our field just in case we were building a further building in the future. So we're trying to make the building sit in the landscape quite effectively, and tried it not to look like a blot on the landscape. So use of colours, the use of the design helped us a little bit with that. But we also planted lots of things in and around the building. So rather than having a fence, we decided actually we're just going to plant red robin bushes all the way around the boundary, and that will create a natural boundary for our building. We also planted lots of daffodils in the entrance area, again just to naturalise the building within the setting, and hopefully also use them as an element of sort of carbon offset. We also have 8 car charging points which we use internally. So you'll see the bottom picture is actually our vehicles that we can charge up there. They're 3 of our electric vehicles, and we basically run all of our sort of car fleet that are internal vehicles on electric, and that's worked very, very well. They're all very dirty as well, which is why I put a comment on there that they all really need a good clean. But the good thing is we're using clean energy potentially to power them, especially on a sunny day. If we're generating anywhere near 40 kilowatts, that's more than enough to charge probably 2 cars up, as well as the entire building on that utilization of power alone. So what? Why put all these things in place? From our perspective, it's vastly reduced energy costs, in particular with the war in Ukraine and all of the different pinches on power and all those sorts of things. Because we were using a district heating system where, broadly speaking, there was no cost variation because it was based on waste wood components anyway. We had no deviation in our fuel costs during that period at all, when everyone else was having a massive price hike in fuel, so with gas and those sort of things. And even with our electricity, although we've not quite got the feed-in tariff arranged yet, because these things take way longer than I thought they would, but soon when we get those feed-in tariffs sorted out, we'll be offsetting some of our paid electricity against some of our export. And obviously, we wanted to have a lower carbon impact. We've actually just signed up to being investors in the environment. So we're going through our carbon level and all those sorts of bits and pieces to become bronze certified, and hopefully we'll move up to silver and then on to green in the future. So it's one of our CSR sort of requirements as a company, that we want to become a company that has a lesser impact on the environment. So what's the next plan? Well, the next few things that we want to achieve. One is we're going to add 14 kilowatts of battery storage. So obviously it's great to have solar and export it, but it's even better from a business perspective to have electricity that you're utilizing at a cheaper rate. So from the perspective of generating and storing power, obviously if you buy in electricity, you're paying, I don't know, anywhere between 25 and 30p, depending on how much you buy a year. You're only really selling that back to the grid for between 10 and 15p, depending on what sort of deal you've got. If you're storing that and you're utilizing your own power that you're then not having to buy back off the grid, obviously those units that you're generating are worth way more to you to reuse than they are to you as a sell back. So especially if you're not buying them off the grid at that point. So we're going to add 15 kilowatts of storage that I think will actually offset quite a considerable amount of our overnight power. We want to achieve bronze level investors in the environment certification. So again, that's will help us measure our power far more effectively, and also the impact of some of the things that we're putting in place to be able to measure the ability of those sorts of bits and pieces, and see how effective the changes that we are making are actually having as an impact on our carbon footprint as well as our costs. Because, you know, from a business perspective, if you can do these sorts of things and they have not only an environmental benefit but also a cost reduction benefit, then that is a win-win. Why would you not go ahead with that sort of an investment? And especially when lots of the investments are also capable of gaining grants against them. We were lucky enough to gain a grant to pay for a lot of our solar panels on the roof, and so these sort of things can be used to offset. As I said earlier, we're looking to add additional solar and wind power on the roof. We've got quite a lot of roof space up there, so potentially we could add quite a lot more additional space or additional power generation, and we would definitely like to add some solar water heating. I happen to have that at home, and I know it works really, really well, especially in the summer months where we probably don't have to warm up the hot water using any other source for about 5 months of the year. We want to adapt the green spaces outside as well, so we'd like to sort of make those spaces a bit more environmentally pleasing, so by adding trees and seating areas and those sorts of things. And we also want to increase our use of battery vehicles, you know, which, if we're offsetting that against the fact that we're generating our own power through solar, then there is no greener way to run a vehicle if we're, you know, producing the electricity within those sort of methods of generation. So it's been a very interesting project to work through, and as I said before, when you've got the opportunity to build a building from scratch where you can implement these sort of solutions as you're putting the project together, it does make life a lot easier to put these sort of things in place than potentially it is to retrofit. But, you know, even adding sensors onto walkway areas and areas where you potentially you know, got traffic flow but not necessarily anyone in that space for any given amount of time, adding those sort of solutions is very straightforward to do. Swapping to LED lights is relatively straightforward to do, and has an immediate impact on your power use. So it's well worth thinking about these sort of different solutions. And even adding sort of solar, you know, power, the costs have reduced so much compared to when I did a solar panel array back sort of 10 years ago. I probably spent the same amount of money on a half the amount of power array than I spent this time on a 40 kilowatt array. So the prices are getting better. The ability of the solar panels to generate more power from the same amount of space is considerably better. So, you know, it is well worth looking at these sort of options, you know, if you're able to either win a grant or, you know, put the funding aside to be able to do these sorts of things. So that kind of wraps up all of the things I was going to say in and around our building. I'll move it on to the next slide for you, Heather, which is around about our next few WeCan SELCAN events that we've got coming up, which hopefully Heather will go over with you.
Lovely. Thank you very much, Phil. That was really interesting. It just shows how much you can really achieve when you get that sort of optimal building design correct. And yeah, really interesting project, and shows just how much you can achieve when you really make that big commitment as well. I wondered, did you have any challenges around sort of getting staff on board or that type of thing, or were they sort of really behind the project from the get-go?
I would say probably it helps being the owner. So there's nobody else kind of pushing against me to make a decision. You know, I could almost bulldoze my way through ensuring it happens to a certain extent. But no, everyone's on board with things like, you know, there's logic with things like sensors in movement areas. We had a bit of fun and games getting the balance right with the heating, because we only have one thermostat, and the thermostat happens to be in our building. And when the people that rent our other office, you know, potentially if it's up to heat in here and not quite up to heat in there. So we had a bit of fun and games getting who was in control of the thermostat. That was probably the biggest challenge, to be honest. But other than that, you know, everyone's completely on board with electric vehicles, solar power and all of those sorts of things. And, even down to waste management now. We've now got an Ark Green team that's made up of 4 of us. And, people will rap somebody on the knuckles if they put a recyclable thing in the waste bin, which is fantastic, and then that starts to self-police and people just start getting used to the fact that, they've got to recycle bits and pieces in the right way. So, it just becomes embedded within the culture. And I think if you can get to that point, that's what we're aiming for.
Yeah, absolutely. That's absolutely. It's a measure of success, I think, isn't it? Definitely. And I think it's the most common office argument about the heating controls, no matter what the heating system is. So lovely.
I think
Thank you.
The thing that occurred to me really during that your presentation, Phil, was just something that's kind of cross-cutting is the effective conversations, isn't it? Is actually engaging with the people around you. You found, next door you could use their boiler system, and being cheeky. If we on Boston hadn't have, kind of realised that there was a local landfill site that we could potentially put some materials in, we wouldn't have done that. And if we hadn't approached them, hadn't spoken to them, it kind of really shows why you should be having those conversations. If you see somebody with solar panels on the house or on their business, why don't you ask them about it? See
Absolutely.
They might tell you about a grant.
Absolutely. And that throwaway comment that we had when we were talking about the land purchase ended up with this infrastructure. And again, I can't tell you that the pipe connecting here to them was a cheap thing. That was really expensive. It's like a 20 centimetre pipe with a heavily insulated that runs in the ground. But, we don't have a boiler. We don't have to have a gas supply. We don't have to waste energy in heating water when there is a boiler. I don't know why I want to point, but it's about 500 metres in that direction that's already doing the job. And without that sort of chance comment and asking the question, we would never have got to that point. So absolutely, it completely is about that, the whole communication thing.
Yeah, and it's great to see that sort of collaborative approach that both of you used in your projects, and it's something that we will all probably need to do more of in future. But it's great to see the impact of those on these major projects. So yeah, wonderful. Okay, I don't think we've had any other questions in the chat, so we'll wrap up there for today. But thank you both for the great presentations, and thank you to everybody on the call who's attended. If you are interested in any upcoming sessions, we've got the next webinar in a couple of weeks' time where Georgia's coming back to talk to us a little bit more about the Sustainable Development Goals. And then we've got another couple of webinars following on from that. So if you'd like to register for those sessions or find out more about SELCAN, please drop me a line. My email address is on the screen, or equally you can register through the Microsoft forms that you've used for this session.